Logarithms in base 10, example 2. Use your calculator to write the following in the form 10 to the power x, giving x to 4 decimal places. Okay, so once again we're going to be using that a to the b equals c is equivalent to log to the base a of c being equal to b. So we want a situation where 10 to the power x is equal to 5. That's the x we've got to find. So that's an exponential statement. We want to change it into a log statement. So what we're going to have is log to the base 10. I could have just written log. So log to the base 10 of 5 is equal to x. And then we just need to calculate that. So we'll bring in the calculator. So my log button is just here. That's a log to the base 10. So I'm going to do log of 5. And that gives me 0.6990 to 4 decimal places. So 0.6990, correct to 4 dp. And so we can say that 10 to the 0.6990 is equal to 5. Now we just want to do the same sort of thing for the 50 here. So we have 10 to the power x is equal to 50. Change that to an equivalent log statement. So I'm just going to write LG this time. So LG 50 is equal to x. And then we can calculate. And in fact, here what I'll do is I'll just go back and just edit that 5 into a 50. And that gives me 1.6990. 1.6990. Notice it's just one more than this one. We'll see why that works a bit later. And therefore 10 to the 1.6990 is equal to 50. And we just have one more example to go. So 98. So 10 to the power x is equal to 98. An equivalent log statement would be that log 98 is equal to x. Then we calculate. Remember that log to the base 10 of 100 will be 2. So we're expecting that this should be just a bit less than 2. So what I'm going to do is I'm just going to go back and edit that into 98. Oops, I'll just do it again then. Log 98. And that gives me 1.9912. So 1.9912. And therefore we can say 10 to the power 1.9912. So untidy. 9912 is equal to 98.